19, number 4. So here we have a cylindrical barrel with a diameter of 2 feet over here. Now notice that diameter doesn't change throughout the cylinder, of course. And then, as shown in the figure above, the water drains out through the valve, not shown at the bottom of the barrel, at the rate of change of the height, h, of the water in the barrel, with respect to time. So this is the HDT given to us. All right. H is measured in feet, and T is measured in seconds, and volume is given over here. Find the rate of change of the volume of the water at the in the barrel with respect to time. Okay, so we are looking at dV/dt. That's what we're looking at. How would you be able to calculate the dV/dt? So let's try to look at this one for a second. So part A, here we have V is equal to pi r square h. But here, you get to realize the radius is constant. It doesn't change, which is equal to 1. So this can be rewritten as pi h, because 1 squared is equal to 1. Now I'm going to take the dV/dt here. dV/dt is equal to pi and then dH/dt. We are taking the derivative implicitly. And then this basically means we realize that dH/dt was given in this case. So we have negative pi over 10 square root of h. That's what we have. But h is equal to, what do we realize? 4 feet. So then what we end up getting is when you're going to plug in 4 in place of h, which becomes 2. So we get negative 2 pi over 10. In other words, negative pi over 5. And they want us to indicate the unit of measure. Rate of the change in volume is cubic feet, because this is feet. Cubic feet per second. So that's basically what's happening. Now, let's look at part B here. When the height of the water is 3 feet, is the rate of change of the height respect to time increasing or decreasing? Notice that is the rate increasing or decreasing. So the word increasing and decreasing implies that we have to take the derivative. Derivative of the what? Derivative of the rate. In other words, then we have to take the second derivative here, because first derivative is already given to us. We're going to take the second derivative, which means, what's the derivative of square root of h? 1/2 comes to the front, so we get negative 1 over 20, and then h to the negative 1/2 power, so we end up getting 1 over square root of h. But by the chain rule, we're going to have dH/dt, which was this expression already. Negative 1 over 10 square root of h. Now, one funny thing about this is that these square root of h's cancel away, so we get 1 over 200. No matter what the value of h is, it's always 1 over 200. And we realize that this is greater than 0. So therefore, what do you realize? Since the derivative of the rate is positive, we realize that increasing the rate is increasing when h is equal to 3. So that's basically what we can say. Let's look at part C here. To get part C, they gave us that when t is equal to 0, our height was 5 feet. Use the separation of the variable to find out h. All right, so let's look at this one. So what I can do is I can say, hey, dh over h, square root of h is equal to negative 1 over 10 dt. That's how I can separate them. And of course, we're going to integrate both sides. Then my left side now becomes, this is negative 1/2. So adding 1, then it becomes positive 1/2. And then divide by 1/2, that becomes 2. 2 square root of h. My right side is negative t over 10 plus c. What they told us was t was equal to 0, and then h was equal to 5. So when I plug in 0 here and then 5 here, then we get to realize that c must be 2 square root of h. 2 square root of 5. Then here what we can do here now is I can rewrite this one as 2 square root of h equals negative t over 10 plus 2 square root of 5. I can divide whole thing by 2, then square root of h is equal to negative t over 20 plus radical 5. To get rid of the radical, h is equal to negative t over 20 plus radical 5 quantity squared. That becomes our final answer. Alrighty. So with that one, we are done with number 4. See you at the next question.